So you guys, we're going to talk about the the identity matrix today. And the identity matrix is a matrix that you can multiply times a matrix and get the matrix that you multiplied times the identity matrix. So I kind of think of it as like the one of the matrices. You know, if you had like A times 1, you would get A, right? Okay, so I think of the identity matrix as sort of like a 1. If you multiply one matrix times the identity matrix, you're going to end up with the matrix that you multiplied times the identity matrix, okay? So on our next slide, we have a little bit more description about the identity matrix. An n by n square matrix with 1s down the diagonal from the upper left to the lower right and 0s elsewhere is called the multiplicative identity matrix of order n. This matrix is designated by I sub n. For example, here you have I sub 2, here you have I sub 3, and the identity matrices that are associated with them. The identity matrix is only a square matrix, okay? So you could have a 4, a 5, a 6, but bottom line is the identity matrix will only be a square matrix. That's why it says the n by n. The amount of rows is equal to the amount of columns with the identity matrix. Okay? So we're going to talk about the multiplicative inverse of a matrix. The multiplicative inverse, the multiplicative identity matrix, I sub n, will help us to define a new concept, the multiplicative inverse of a matrix. To do so, let's consider a similar concept. The multiplicative inverse of a non-zero number a. Recall that the multiplicative inverse of a is 1 over a. The multiplicative inverse has the following property. When we multiply a times 1 over a, we get a 1. When we multiply 1 over a times a, we get a 1. So we're going to see that when we multiply a matrix times its inverse matrix, we will get the identity matrix. That's what we're going towards right now. And that's what this next slide is all about. When you multiply a matrix times its inverse matrix, you will get the identity matrix. Okay? Okay, so down below there we have this paragraph that talks about matrix multiplication and how it's not commutative. So we've seen that when you multiply a times b, that's not necessarily the same result as when you multiply b times a, right? So when you're multiplying a matrix times its inverse matrix, you have to do that in both orders, a times the inverse of a and the inverse of a times a, to show that it's equal to its identity matrix. Our first example is going to involve that. Okay? No, don't copy this down. All right? We're gonna work on an example together in just a second. Okay? So, an example 1 says that we want to show that b is the multiplicative inverse of a, where a is equal to this matrix and b is equal to this matrix here. We have a times b. If their inverses, if b is the inverse of a, then we should get the identity matrix, right? And if we multiply b times a, if b is the inverse of a, we should get the identity matrix, right? And that's how we would prove it, just multiplying those two matrices together. And that is the work here for this particular problem. Row times column, rows times columns. What we're going to do right now is get our own practice with this one here. We're going to see that these two, we're going to multiply a times b and b times a and see if it's equal to the identity matrix. If it is, then b is the multiplicative inverse of a. So let's go ahead and start off with this one. So we're going to multiply a times b And that should give us the identity matrix. Okay, so what we want to think about are the rows times the columns right now. Rows times columns. And first of all, you can multiply these. That's an order of 2 by 2. That's 2 by 2. The 2's match up. That means the number of columns here match the number of rows here, so you can multiply them. And your resulting matrix is going to be a 2 by 2. So that means that whatever you get here, here, well, whatever you get over here is going to be a 2 by 2. And you're going to have 4 different elements. So we have row times column, 2 times 1, plus 1 times negative 1. 2 times 1 is 2, plus 1 times negative 1 is minus 1. 2 minus 1 is a 1. So that's the start there. So you guys, we should have found with this particular problem here that when you multiply A times B, you get the identity matrix. When you multiply B times A, you get the identity matrix. What I'd like to do today is show you guys how to deal with matrices on the calculator. That's why I told you to grab the calculator at the very beginning. So what I'd like you to do first is turn on your calculator. Okay, so first thing I'd like us to do is actually go to the matrix button. So we're going to hit second, and then the fourth button down in the first column. So we could say that's row 1. I'm sorry, row 4, column 1. All right. So now what you guys want to do is go over to the edit button, scroll to the edit button, and hit enter. That allows you to change the order of your matrix first thing. So we're going to hit a 2 by 2 matrix. 2 by 2 matrix, and then hit down to go into that matrix. So now we're going to actually enter in the values for the 2 by 2 matrix. Somebody read off to me the numbers for matrix A. What were the numbers?
2, 1.
2, hold on. 2, 1.
Yeah, that one.
1, and 1?
Yep.
Okay. So now, what we need to do is to enter in matrix B. So I'm going to go to second and matrix once again. And I'm going to go to edit, scroll down to B, and hit enter. So right now, I'm going to enter in the different order. I have a 2 by 2 matrix. 2 by 2 matrix. And somebody read me matrix B. 1.
Negative 1.
Negative 1.
Negative 1.
Negative 1.
2.
And 2.
Yep.
All right. Okay, you guys, now what we need to do is to hit second and then mode. That takes us to the quit, which gives us a blank screen. This is where we perform all of our operations. We have to go to this screen first. And then now we're going to go back to the matrix button. So second matrix. And now we are going to call the matrix A into the blank screen now. Just by hitting enter, it calls matrix A into the blank screen. Now we're going to click on second and then matrix again, and we're going to go down to matrix B and click on it, and that calls matrix B into our blank screen. So now we have matrix A times matrix B, and we can hit enter, and voila, it multiplies matrix A times matrix B. Isn't that special? So now what I want to do is I want to multiply matrix B times matrix A to see that I will get the identity matrix. I'm confirming what I did by hand. So now, instead of calling matrix B and then matrix A once again, I'm going to go ahead and hit second, enter. That gives me the previous thing that I typed. And I'm going to go and scroll over to A. I have to hit delete for A. and then go to the right side of B. But now I don't have to call matrix B. It's already there. I'm going to go to second matrix, and then A, hit enter, and I get the identity matrix. So, for example 2, we want to find the multiplicative inverse of matrix A here. We want to figure out what the multiplicative inverse of this particular matrix is equal to. So, what I want to do right now is I want to utilize a system of equations in order to solve for that multiplicative inverse. And so what I'm going to do is set up a couple of some matrices multiplied. So I do know that when I multiply this matrix A times its multiplicative inverse, and I don't know what it is, but I do know that it is a 2 by 2 matrix. When I multiply A times its multiplicative inverse, which is a 2 by 2, and whatever elements are in there, I don't know right now, but I can use unknown values, which are going to be x, y, z, and w here. I know that when I multiply, I will end up with the identity matrix, right? So what I can do from here is multiply these two matrices together and end up setting up a system of equations. So let's go ahead and start off with that. We got to think about row times column, right? If I multiply row 1, column 1, if I multiply row 1, column 1, that will be equal to this first spot right here, right? Row 1, column 1. So I have 2 times x plus 1 times z. That should be equal to 1. All right? And then I also know that row 2, column 1, row 2, column 1 will be equal to row 2, column 1. So I have a 5 times x plus 3 times z, which is equal to 0. So I have a system of equations there, 2 equations, 2 unknowns. I can actually solve for x and z. So I'm going to go ahead and figure out y and w. I'm going to set up a system of equations with y and w. I know that when I multiply row 1 in column 2, row 1, column 2 will give me this location here. So I have row 1 times column 2 now. 2 times y plus 1 times w is equal to 0. And now I'm going to multiply row 2 and column 1. I'm sorry, row 2, column 2 to get row 2, column 2. So I got 5 times y plus 3 times w. And that's equal to a 1. So you guys, we have systems of equations that tell us that we can figure out what x, y, z, and w are equal to. So let's go ahead and how about I figure out the red equations? How about I solve for the red equations and you solve for the black equations? And we come together and figure out what x, y, z, w are equal to. So let's see here. For the red equations, I'm going to multiply the top by a -5, the bottom by a 2, and that gives 10x, negative 10x, plus, minus 5z is equal to a -5, and then I got a 10x plus 6z is equal to 0. And if I add straight down, 10 minus 10 crosses a 5. Minus 5 plus 6 is z there. 1z. And then we have a minus 5. So z equals minus 5. So 5, substitute in minus 5 into z. I end up with 2 times x minus 5 equals 1. And I end up with x equals a 3. So I got x and z. What did you guys get for w and y? 2? Alright, so we have x, y, z, w. So this is our multiplicative inverse of the matrix. Now you guys remember that if I really wanted to prove that they are multiplicative inverses, I would have to multiply this inverse times this matrix here, right? Okay. We're not going to do that right now. We're just going to move on. Okay? This checkpoint here is for your practice. We don't have any homework associated with this section right now, so it is for your practice. Okay, so you guys, what we did is we essentially set up a system of equations using matrices to solve for the multiplicative inverse of a 2 by 2 matrix. But there's actually a formulaic way of doing it, and so I figured I'd show it to you. It says here that if you have this matrix A with A, B, C, D, then you can find the multiplicative inverse by taking 1 divided by A times D minus B times C, and treat that as a scalar times this matrix here, with D in this position, the B now negative, the C now negative, and the A now in this position. Okay? So, here I have some work shown for you. There's the definition still there. So, I don't want to spend a lot of time on this because I do just want to get to our last problem, which involves using an inverse matrix to solve for the unknown values in a system of equations. And I think you guys will appreciate that problem more than any. Okay, so you guys, today we're going to use the inverse matrix in order to solve a system of equations. And what we have here is if matrix A times matrix X is equal to matrix B, if this has a unique solution, so if this actually has a solution, then X is equal to the inverse of A times B. So we're going to use these two ideas, AX equal B and X equals the inverse of A times B, to solve a system of linear equations. I think this idea is going to make a lot more sense when we actually go through the example, but to show you how they actually go from this statement here to this statement here, I've broken it down right here. So we have AX is equal to B. To isolate the X value here, multiply both sides by the inverse of A, and the inverse of A times A will actually result in the inverse matrix, and when we multiply the inverse matrix times X, we'll just get X all by itself, and the inverse of A times B will result in this X value. So like I said, I think this will make much more sense when we're working through an example. Are we ready for that example? Okay. So you guys, in example 5, we want to solve this system of equations using the inverse matrix. So the first thing we want to do is we actually want to set up a system of some matrices based off this system of equations here. So this first matrix down here, A, is literally each one of the coefficients on the left here. And if you look here, this x has a coefficient of 1, this y has a coefficient of -1, this z has a coefficient of 1. And you can see that right here, 1, -1, and 1. Okay? And then in the second row here, we don't have any x value, so we can think of that kind of as like 0 times x. And then we have a -2 and then a 1. Here we have a 0, a -2, and a 1. And then in the third row here, we don't have any z values, so we can think of that as like 0 times z. So in our third row here, we have a -2, a -3, and a 0 here. So that's like our coefficient matrix. So far, so good? Coefficient matrix, yes? All right. So we have the coefficient matrix multiplied times this matrix here, this unknown matrix that has the unknown variable values in there. So we have the x, the y, and the z in there. And the reason why that's so is because think about row times column. If we multiply the row of matrix A times the column of the matrix X, we have 1 times X plus -1 times Y plus 1 times Z, and that will result in row 1, column 1, which is equal to 2. So literally that's just this top equation here. So far, so good? All right, so if we multiply row 2 times column 1 here, so the matrix A row 2 times matrix X column 1, we have 0 times X, this is 0x. We have -2 times Y, which is a -2y. We have 1 times Z, which is a plus 1z there. And that's equal to row 2, column 1. And then finally we have row 3 times this column 1 here. -2 times X plus -3 times Y plus 0 times Z is equal to that spot right there. Okay? So are we all good on how to take the system of equations and rewrite it using matrices? Does that make sense to everybody? Yeah?
Yes.
All right. So in order to solve for x, we would multiply the inverse of a to both sides, and then x would give us, we would get x by the inverse of a times b. And by solving for the inverse of x, that will give us what x, y, and z are actually equal to. So what we're going to do is just go through an example right now together. So our first goal right now, you guys, is to just set up the system of equations here. Set up the matrices using the system of equations. All right. So first thing we want to do is write the coefficient matrix. So we have a 1x, and we have a 0y, and a 2z there. So I have a 1, a 0, and a 2. And then I have, for the next row, I have a -1, a 2, and a 3. In the next row, I have a 1, a -1, and a 0. So 1, a -1, and a 0. And if we were to multiply the coefficient matrix times the variables here, the variable matrix, we would end up with the left-hand side of the equations. And that would be equal to those constants there. So we have 6 minus 5 and 6. So we good on how we set that up so far? That's really probably the most difficult part of this right now. Now you guys, we're calling the coefficient matrix A. We're calling the variable matrix X, and we're calling this constant matrix B. And what we want to do is we want to solve for those unknown values. And the way that we do that is with X equals the inverse of A times B. So we could go through and we could solve for the inverse of A and multiply it times B to solve for those unknown values. But I think it'd be a little bit easier to actually just solve the system of equations, right? So let's go ahead and just use our calculators to solve, all right? That's what I'm going to show you guys how to do right now. Use our calculators to figure out what those unknown values are. So we have to go to our calculator and plug in matrix A and matrix B right now. So I'm going to need your guys' help right now, okay? I'm going to go to Edit, and I have a 3 by 3 matrix. So somebody help me out. What was in that 3 by 3 matrix? What was in that coefficient matrix? 1, 0, 2, minus 1, 2, 3, 1, minus 1. Oh, crumb. Okay, so that was a minus 1 there?
Yep.
And 0. Okay, so now I have to enter in matrix B. So I'm going to go second, and then matrix, and then go to edit, and then go down to B, and I'm going to enter in a 3 by 1. What do we get when we enter in the 3 by 1? What is it? 6, negative 5, and 6, negative 5, and what?
6.
Okay. So I have matrix A and I have matrix B. What I need to do is I need to go to the blank screen where I do my work, and I need to call the matrices over to that blank screen. So let's go ahead and do a second mode, which takes us to the blank screen. I'm going to clear it away. And I need to enter in the inverse of A. I need to enter in what A is actually equal to first. So I'm going to go second, matrix, and hit name A, and that shoots A over to the blank screen. And then from here, I want to enter in the inverse of A. Well, the inverse is found in the fourth row and the first column. That says the inverse of A there. And now I need to multiply that times the matrix B. So I'm going to go to second, and then matrix button, and B. And so that says the inverse of A times B. And then if I hit enter now, that gives me X, Y, and Z.